All right, welcome back to the second episode of this tutorial this afternoon. So this question we are asked in the circuit above, find I, that is the current I, by using superposition principle. So superposition is actually a principle that when you have different sources across board, you just kill the other sources, or you zero out or shut out the other sources and then focus on one. So that's the hinge or the main backbone of superposition principle. So we'll be applying that superposition principle. And please, before I go further, I would like us to grasp the principle and grasp what it entails as far as circuit analysis is concerned. So for when you're applying superposition to circuit analysis, if you are applying superposition to that, you know that if you want to like eliminate a voltage source, you have to replace that voltage source with a short circuit. Then if you want to eliminate a current source, you replace it with an open circuit. So please, let's not get it mixed. For voltage source, you replace it with a short circuit. For a current source, you replace it with an open circuit. So this is what we'll do. We'll consider each of these sources in turn. We'll consider 3 ampere. This is a source, this is another source, this is another source. So we consider this and then we'll zero out these ones. And then we'll consider this and zero out these ones. And we'll consider this and zero out these two. So we take them one after the other. And in the process, we get I1, I2, and I3 and the rest. So for let's consider, let me start from my right hand side. Let's consider for the 3 ampere source, we would have to zero out this circuit. So if you zero out this circuit, that means you replace this, the voltage source, you replace it with a short circuit. This is the current source, you replace it with an open circuit. So let's draw the equivalent circuit. How does it look like? This is your resistor, if you still remember. Then this is your current source, which will replace with an open circuit. Then this resistor is still there, so you replace, or you have that resistor still there. And then this is this voltage source you replace with a short circuit, right? And then you have your current source in this case. So your current source of 3 ampere. So the voltage source was originally here, the current source was here, but then remember, and then this is your I1 in this case. Remember, there's a resistor here. Least I forget, that's a 2 ohm resistor. This is a 1 ohm resistor, and this is a 1 ohm resistor. So before I forget, this is I1 because it's the I corresponding to 3 ampere. So for this one, you get an I2 and then an I3, and then we'll add everything together. So by inspection, you don't even need to talk much. By inspection, you know that this I, in this case, because this is more like these like two parallel circuits, this has a resistance of 0 ohm. So I1 would be equal to this resistance, sorry, the other resistance, um sorry, I1 is the current in this branch, right? So it's going to be this resistance, that is, remember, it's going to be R2 divided by R1 plus R2 times the total I. This current divider principle. Whereas the R2 is the sum of all these, sorry, the R2 is this resistance here, right? Then the R1 is equal to the sum of all these ones. So where R2 in this case is equal to this resistance. The resistance between a short circuit, remember, for a short circuit, the resistance is 0. Then R1 in this case is the resistance across this very one, this all these places. That will be equal to 1 plus 1 plus 2, 1 plus 1 plus 2. Because they are in series, you have this to be 4 ohm. So our I1 in this case becomes 0 divided by 4 plus 0 multiplied by total I is the 3 ampere current, and then you get 0 ampere. This is for the 3 ampere source. So I'm done with the 3 ampere source. Then for the next source is for the 6-volt source, right? For the 6-volt source, we concentrate on this 6 volts and then we zero out these other sources. Remember, for a voltage source, sorry, for a current source, you open up the circuit. So for a 6-volt source, we still draw a circuit starting from the left. You have your resistor, your 1 ohm resistor, that's this very resistor from the left. Then you take it to this place. Then since we are no longer concentrating on 1 ampere current source, we replace it with an open circuit, right? Then you have this resistor here, and you have a voltage source like this voltage source. We want to concentrate on 6 volts, and then you have your current in this case is going to be I2. Then your resistor is still there, right? Then you have this to be an open circuit. So I believe everybody is following. This is an open. There should be a current source here, current source here, but since we are concentrating on the 6 volt source, we just leave it there. So this is a 2 ohm resistor. This is a 1 ohm resistor, and then we are looking for the current due to this 6 volt source alone, which is called I2. So how do we find that current? Remember, this is just a simple series circuit, right? This is an open circuit, this is an open. So this is just a simple series circuit. We are not concerning ourselves with the open circuit because as far as we are concerned, as far as the rules of circuit analysis is concerned, as good as they are not even there. So you cut them out. This open circuit, you can cut them out, and then you still get a neat or single open circuit, sorry, a single closed circuit. So if you apply KCL like this, or maybe in a favorite manner, current entering like this is going to be plus minus, current going like this here is going to be plus minus, current going like this here is going to be plus minus. Then the voltage has a polarity already. So let's apply KVL around the loop. By Kirchhoff's voltage law, we have the current. This is a single current I2 passing through the hole. So there, here is also what? I2. Here is also I2 because you have a simple series circuit. So from here you get 1 time, because it's plus, because the first time we are analyzing like this is going to be 1 times I2. I'm done with this. Then here is going to also be plus 1 times I2. The 1 is the 1 ohm resistor, the I2 is the current. Then here is going to be plus 6 volt because this is a positive sign. Then here is going to be plus 2 times I2, and back to this place, everything is equal to 0. So I'm making I to subject formula. So this is going to be I2 plus 2I2. That's going to be 6 plus 4I2 equals to 0. So from here, you make I2 subject formula. This is going to give you minus 6, sorry, I2, yes, minus 6 divided by 4. And this is 3 over 2. And that's minus 1.5 ampere, right? So that's the value of our I2. So we are done with finding I2. Then for the third one, for this third source now, this very one, for the 1 ampere source, so you are considering the 1 ampere source. For the 1 ampere source, remember this, and this for this, and then this is also for this. That's this very one. Now how do we rectify the issue? We rectify the issue for this very one by we short out this, we zero out this, and we zero out this. We zero out this with an open circuit, we zero out this with a short circuit. So at the end of the day, we will have an equivalent circuit that looks like this. If you follow me, you still have your resistor to the left, right? Then you would have this current source that we are now interested in, which is the 1 amp current source. Then you would have your resistor again, 1 ohm resistor. Then this is a short circuit. Remember, we short circuit this, and then we open circuit this, right? Then we have a current. Current is always in this place. That's going to be I3 because we are on the third time. We are doing the third superposition or the third source. So I'm labeling them I1, I2 in that fashion. So this is 1 ohm, this is 1 ohm, and this is 2 ohm. So we are left with just a simple series circuit like this. Sorry, a simple 2 parallel circuit in this case. And then I'm going to use my current divider rule because we have 2 parallel circuits like this and this. So this branch is going to be branch 1. This branch is going to be branch 2. So in this case, by current divider rule, if you check your current divider rule, your I3 by current divider rule is going to be, if here is the resistance in this branch is branch 2, and the resistance is, sorry, branch 1, and then the resistance in this place is branch 2, then it's going to be R1 divided by R1 plus R2 multiplied by the total current powering the circuit. Now, let's not get it twisted. This resistance is going to be your R1 because it's the resistance in the other side, not in the circuit you are considering. So your R1 in this case is going to be 1 ohm, and then your R2 in this case is going to be is going to be the total resistance in this branch, which is equal to 1 plus 2, which is equal to 3 ohm. So I'll substitute this. I'll get I3 is equal to R1, which is 1 divided by 1 plus 3 multiplied by I is just 1. That's the total current is 1. So if you do this very well, this is 1 times 1, this is 1 all over 4, which is 0.25, right? So our I3 is equal to that. So by superposition, our I is equal to I1 plus I2 plus I3. So that's I is equal to I1. Remember, what's the value of our I1 here? That's equal to 0. Check here. Check this 0 ampere plus what's the value of I2? We found I2 here to be minus 1.5. Then plus I3 is 0.25. So if you add everything together, you'd get minus 1.25 ampere as your final answer. So this is the current in this branch using superposition principle, and you can actually use any other principle, maybe nodal or mesh analysis, to verify that this answer is also correct. So that is it for this question. Thank you for staying with me and have a nice day. Let me zoom in, please. I hope we've been following. So I'm kind of like speeding or rushing through this just to like save time, so that I also compress this video to a reasonable length of time. So once again, thanks for watching and have a nice day. This is Superposition. Have a great day, just like I said.